Introduction to Haptics. Imagine a world where technology doesn't just talk to us or show us things, it lets us feel them. This is the promise of haptics, the science of touch, derived from the Greek word haptesthai, meaning to touch. Haptics bridges the physical and digital worlds by simulating sensations like texture, vibration, and resistance. From the rumble of a game controller to the precision of a surgical robot, haptics transforms how we interact with machines. Today we'll explore how this technology evolved, how it's reshaping industries, and where it's taking us next. Historical evolution. Haptics isn't new. Its roots go back to the 1940s, when pilots trained in flight simulators with mechanical force feedback to mimic the resistance of real controls. By the 1960s, General Electric's handyman robot used early haptic principles to manipulate objects remotely. Fast forward to 1997, and Nintendo's Rumble Pack brought vibrations to gaming, making explosions and crashes feel real. The 2000s saw haptics enter medicine with systems like the Da Vinci surgical robot, giving surgeons tactile feedback during operations. Today, we're in an era of ultrasonic waves, magnetic resistance, and full-body suits. But let's unpack how we got here. Core technologies. Behind every haptic experience is a symphony of engineering. In the 1980s, ERM motors delivered basic vibrations in pagers and phones. By the 2000s, linear resonant actuators, LRAs, made smartphone alerts quieter and more precise. Now, piezoelectric systems simulate textures. Imagine dragging your finger across a screen that feels like sandpaper. For VR gloves like Sense Glove, magnetic braking creates resistance, tricking your brain into feeling virtual objects. And suits like Tesla Suit use electrotactile stimulation to make your muscles sense raindrops or punches. These technologies aren't just incremental upgrades, they're redefining what touch means. Haptic gloves in VR. Gloves like Sense Glove and Haptics are turning science fiction into reality. These aren't just controllers, they're portals to virtual worlds where you can grip a tool, sense its weight, and feel its texture. Sense Glove, for example, uses magnetic resistance to simulate picking up a wrench or turning a valve, while Haptics employs microfluidic air pockets to mimic pressure and texture. Industries from automotive to healthcare are already using these gloves to train workers, prototype products, and even practice surgeries, all without touching a physical object. Deep dive, Sense Glove. Let's zoom in on Sense Glove, a leader in enterprise VR training. Its secret, a magnetic braking system that adjusts resistance in real time. When a BMW technician practices assembling an engine in VR, the glove makes virtual bolts feel stiff to turn. Surgeons in training use it to simulate the delicate force needed for incisions. Unlike consumer-focused gloves, Sense Glove prioritizes precision and durability. It's wireless, lightweight, and designed for industrial environments. This isn't just gaming, it's revolutionizing how we prepare for real-world tasks. Full-body haptics, haptic suits. But why stop at gloves? Enter haptic suits like Tesla Suit and Haptics Tact Suit. Tesla Suit uses electrotactile feedback to make you feel raindrops on your skin or a punch to your chest. Athletes wear it to analyze movement, while soldiers train for battlefield impacts. The Haptics Tact Suit, with 40+ vibration points, turns gaming into a full-body experience. Imagine feeling every gunshot in Half-Life. Alex. These suits aren't just gadgets, they're tools for rehabilitation, sports science, and hyper-immersive storytelling. Current applications. Today, haptics is everywhere. In healthcare, surgeons use the Da Vinci robot for minimally invasive procedures, while Sense Glove trains the next generation of doctors. Automotive companies like Tesla use haptic pedals to nudge drivers towards safer habits, and BMW prototypes cars in VR. Your smartphone's Taptic engine makes typing feel tactile, and PlayStation's DualSense controller lets you feel the tension of a bowstring. Even retail brands use haptics to simulate fabrics in virtual showrooms. This isn't niche tech, It's woven into our daily lives. Future trends. The future of haptics is even wilder. AI-driven systems will adapt feedback to your behavior. Think gloves that learn how you grip tools. Neurohaptics could bypass devices entirely, sending touch signals directly to your brain. Companies are already merging gloves, suits, and AR glasses for holistic experiences. Imagine a firefighter feeling heat through a suit, while AR glasses map escape routes. But with great power comes responsibility. How do we protect biometric data? How do we ensure accessibility? These are questions we'll need to answer as touch becomes a language. Conclusion. From the clunky force feedback of 1940s simulators to gloves and suits that blur reality, haptics has come full circle. It's no longer about making devices buzz. It's about making digital interactions human. Whether training a surgeon, rehabilitating a patient, or losing yourself in a game, haptics reminds us that touch is primal, universal, and irreplaceable. As one pioneer put it, the future isn't just virtual, it's tactile. So, the next time your phone vibrates, remember, that's just the beginning.